Hello, welcome back for part two of understanding domain. And in the last video, we talked about sets and how sets make functions and how that relates to domain and range. We looked at various parts of this first example where we had different functions and we determined domain and range. And we weren't looking so much at context. We did a little bit in the storage room, but that's what this video is about. It's really about how putting these functions into context, where domain and range are really going to matter. And so let's just get started. The function s equals negative 16 t squared plus 10t plus 2 models the motion of a football. That is the polynomial from the last video. S denotes the height in feet above the ground, and t is the amount of time in seconds in the air from the moment it is kicked. So we have this downward parabola, ball goes up, back down. And what I want to do is find domain and range. So right off the bat, we can kind of make some restrictions. And so I'm going to go ahead and do that. First of all, we know that concerning our domain, our time has to be greater than or equal to 0. Can't have negative time. So that's just something we have to keep in mind when we're stating our final domain. Same with the range. When we kick this ball upwards, it's going to fall back down, and then it's going to hit the ground. And if the ground is 0, we can't go into negative grounds. Or now the ball is barreling towards the core of the earth, and I personally can't kick a ball that hard. So that is something that we have to take into account. So our S values also have to be greater than or equal to 0. And so we're just going to kind of keep that in mind, but we're not done yet. And that's because we made this range restriction, and we don't actually know what that did to the domain. So here's kind of what we're going to do. This is what our function sort of looks like. That's really rough, but downward parabola. And we want to find the times that will keep this ball greater than or equal to a height of 0. So we have to look for the time at which it hits the ground, kind of right at this point. Because, it starts out positive, but it's going to want to go negative, and we have to prevent that. And so a great way to do that is to figure out where this function equals 0. And that'll tell us that time right there when the ball hits the ground. So equals 0. This already looks like a factoring situation, but I'll go ahead and tell you factoring doesn't work. We have to use the quadratic formula, and I'm going to go ahead and do that. So first we're going to do negative b plus or minus square root of b squared, 10 squared, 100, minus 4 times a is negative 16, times c is 2. Okay. If you need to review the quadratic formula, I wouldn't blame you. It's a long formula. That's how we do it, and then that's all over 2 times a, which 2 times negative 16 is going to be negative 32. All right, and so we end up getting two t values here, sorry. I was going to say 2 possible t values, and but really only one of them can work. We said at the beginning that t has to be greater than or equal to 0, and we get a negative t value. Doesn't make any sense. We'll cross it out. And so we're really looking at this one right here. And so that is the time at which this ball hits the ground before it becomes negative. And okay, so we've found our official domain. These are the times that make sense in this context. So I'm going to go ahead and, what color do I want? I'll go with red. Domain. Domain is going to be from 0 to 0.784 seconds. And I'm just writing it in this notation. It's easier for me to see. Okay, now we have to look at range, and we're doing the same thing that we did in the last video, where we determined our domain and then we figured out what the actual outputs are that we're going to get from that. But remember that when we're looking at parabolas, it's more helpful to actually look at the graph to figure out what the range is. And that's honestly the case for a lot of functions. You want to think about what the graph looks like and what kind of factors you have to account for, like asymptotes and vertexes and holes and stuff like that. But anyway, I digress. Let's go back a slide and look at the graph of this function. So it's this downward parabola, and we kind of have to think about how this looks now. We started at this t equals 0, initial height of 2. We went all the way up, back down, but then we stopped. We stopped at t equals, I think it was 0.784. We stopped there. So this is what our function looks like now. And we can see that our range, we have a minimum height of 0, but we still have that maximum height of 3.563. So using the graph, range is going to be, I guess I'll write it in the same notation. S is going to be from 0 to 3.563 feet. And that is how we would do that problem. Yeah, so, and that's exactly why domain and range matter. You can see that once we took this polynomial, we put it into context, we had a lot more restrictions than we were when we were just looking at it by itself.